Welcome everyone. We are discussing basic derivatives. We have already discussed derivative of 10 standard functions. Today through this video, I will discuss fundamental results of derivatives and their application. Only the basic one. So, number 1, d by dx fx plus gx, derivative of fx plus gx equals to derivative of fx plus derivative of gx. Derivative of fx plus derivative of gx. So, application. d by dx 2 to the power minus x plus log 2x. Obviously, base is e. This equals to ddx of 2 to the power minus x plus ddx of log of 2x base e. Now we know derivative of a to the power x. With the help of this, we can write 2 to the power minus x into log 2 base e into coefficient of x. Mind it, 2 to the power minus x. Derivative of 2 to the power minus x is 2 to the power minus x into log 2 into coefficient of x, that is minus 1. And derivative of log 2x is 1 by x. 1 by 2x into 2. So, this is derivative of 2 to the power minus x plus this. So, these are the sequential steps. We can write directly this step without showing this one. Number 2, d by dx of similar like for difference minus gx equals to ddx of fx minus ddx of derivative with respect to gx. Application. d by dx of tan x degree minus e to the power 3x. So we can write it d by dx of tan x degree minus d dx of e to the power 3x. Now try to recall the basic formulae. Tan x degree, derivative of tan, this is sec square x degree. Now since it is in terms of degree, you have to multiply it by pi by 180. I have already discussed it in part 2. And e to the power 3x, e to the power 3x into 3. So 3 into e to the power 3x. So we can write it, this result directly. No need of showing this one. This is standard result 2. Fundamental result 2. Number 3, dy dx of constant function. You know, constant function is denoted by c. So derivative of constant function is 0. We are not interested about the proof. Proof can be done, I have already stated, with the help of derivative by first principle. So what is the third result? Derivative of constant function is 0. For example, ddx of 5, this is 0. Not involving x and y, it is considered as constant. So derivative of constant function is 0. And number 4, ddx of c into fx, c outside, constant outside, ddx of fx, ddx of fx. So application, ddx of 5x square, so 5 is constant, outside ddx of x square, and 5 unchanged, derivative of x square is 2x. So finally 10x. So look, we can write it directly, 5 outside then 2x equals to 10x. No need of showing all sequential steps. ddx of 5 into e to the power x by 5. So 5 outside, ddx of e to the power x by 5. Then try to recall the formula, e to the power x by 5. So e to the power x is, e to the power x is e to the power x into coefficient of x. So e to the power x by 5. So fundamental result 1, sum of derivative of their sum, difference of derivative is derivative of their difference, ddx of c is 0 and ddx of c into fx equals to c into ddx of fx. Now application. So I am writing a problem involving all 10 basic derivatives. Suppose y equals to x to the power 1 by 3 plus 2 to the power 3x e to the power minus x log 2x sin x by 3 cos x degree tan 3x cot 100x sec 2x degree cosec 5x plus 3. So this is a function involving all basic formulae. So you have to recall the formulae. So differentiating both sides with respect to x. Differentiating both sides with respect to x. That is dy by dx. ddx of y, derivative with respect to x. I am not writing sequential step. So derivative of x to the power 1 by 3. So n is constant. So 1 by 3 minus 1, 2 by 3. Then 2 to the power 3x. So 2 to the power 3x into log 2 base e into coefficient of x. Then derivative of e to the power minus x. So e to the power minus x into minus 1. Derivative of log ax is 1 by ax into a, that is 1 by x. So this is 1 by x. Sin x by 3. So derivative of sin is cos x by 3 multiplied by 1 by 3. Minus cos x degree. Derivative of cos is minus sin. So minus and this minus is plus. So sin x degree, you know, it is multiplied by pi by 180. I have already discussed it in previous class. If it is degree, you have to multiply it by this. Tan 3x, derivative of tan x is sec square 3x into coefficient of x, 3. Cot 100x, derivative of cot starting with c, so it is negative, cosec square 100x, argument must be same, into coefficient of x, that is 100. Sec 2x, derivative of sec x is sec 2x into tan 2x multiplied by 2x degree. So pi by 180 into 2. Why it is 2? Into coefficient of x, 2x degree equals to pi x by 180 into 2. So coefficient of x is 2 pi by 180. 2 pi by 180. And cosec 5x. It starts with c, so it is negative cosec 5x into cot 5x multiplied by 5 and constant function 0. So y is given in terms of 10 standard function. So this is dy by dx. So use of fundamental results of derivative. So your main aim is to memorize derivatives of 10 standard function. Now this one, y equals to 4 cos square x by 2 minus tan pi minus x plus 2 to the power 3 plus x. So look, we know derivative of cos. So far we do not know derivative of cos square x. So our main aim will be to express the given function in terms of known function. So cos square x by 2, 2 cos square x by 2, we know the formula 1 plus cos x. What is the formula? 2 cos square x by 2, 1 plus cos x. Tan pi minus x minus tan x. In second quadrant it is negative, so it will be tan x. And this one is unchanged. This one is unchanged. So this is simplified form. Then differentiating with respect to x. dy by dx. 2 outside, it is constant. And derivative of 1 is 0 and cos x is minus sin x. Derivative of tan x, simplest one, sec square x. And derivative of 2 to the power 3 plus x. So 2 to the power x, derivative is 2 to the power 3 plus x into log 2 base e into coefficient of x into 1, because it is linear. So we can write it minus 2 sin x. So you can write minus 2 sin x into this. You can write this step directly. So your main aim is to express the given function in terms of known function. So that's why you have to know the formula of trigonometry. Next problem. Y equals to cos x minus cos 2x by 1 minus cos x. So look, this is ratio of two functions. You can use quotient rule, but we do not know quotient rule so far. So our main aim will be to express it in terms of simplified form if possible. So this is x, 2x, this is x. So in terms of same trigonometric function, cos x, so cos 2x is 2 cos square x minus 1, 1 minus cos x. So minus common 2 cos square x minus cos x minus 1 by 1 minus cos x. So it is quadratic function of cos x. So you have to perform derivative. So 2 cos square x, product is minus 2 cos square x. So minus 2 cos x plus cos x minus 1, 1 minus cos x. So minus outside, 2 cos x common, cos x minus 1, cos x minus 1, 1 minus cos x. So minus as it is, cos x minus 1, 2 cos x plus 1, 1 minus cos x. So if you simplify, if you multiply it by minus, so it will be 1 minus cos x, 2 cos x plus 1, 1 minus cos x. So 1 minus cos x cancel, finally 1 plus 2 cos x. So main aim is to put it in simplified form if possible. If you cannot simplify it, you have to use quotient rule. Now dy by dx, derivative of 1 is 0, to unchanged, derivative of cos is minus sin x. So what is the derivative? Minus 2 sin x minus 2 sin x. So look, y equals to this, simplified form, cancel, 1 minus cos x, it will be simplest form, then perform derivative. So main aim is to express the given function in terms of known function. Then y equals to sin x plus cos x by 1 plus sin 2x, 0 less than x less than pi by 2. Now, actually this is trigonometric problem. So our main aim will be to simplify it. So try to recall. It is a problem of compound angle. 1 and 1. So our main aim will be to remove root over sine. So sine 2x is 2 sine x cos x. And for 1 you can write cos square x plus sine square x. So it is cos x plus sine x whole square. So root over 1 plus sine x equals to plus minus or mod x or this one plus minus or mod cos x plus sine x. Now you see the restriction. If restriction is not given, we suppose that x is in first quadrant. But here restriction is given, so cos x is positive, sin x is positive. In this restriction, so sum of two positive number is positive, so it is cos x plus sin x in this restriction. So what is y? Y equals to sin x plus cos x by sin x plus cos x. So this is 1 dy by dx equals to 0, derivative of constant function. So today, through this video, I have discussed fundamental results of derivative and their applications. So, thank you.